Alright, page 2 of the second semester review. So, this one is going to be a y equals, so 1, 2, 3. So no matter what x equals, y is equal to 3. So the slope of this line, so we come in here, just going to zoom in on this one a little bit so I can see it a little bit better. So I see this point here, and actually, pretty easy then, going up 1 over 1, so it's change in y over change in x. So it went up 1 and over 1, so the slope is going to be 1. So for number 17, we have to solve for y. So we want y by itself, so we just need opposite of minus 3, so plus 3 and plus 3. Y is less than x minus 6. So solving for y here is just the same thing. We need to get rid of minus 6. So y is greater than or equal to 1/4 x minus 9. So on this one, is 2, 4 a solution for the inequality y minus x is less than or equal to 2? We could just put these two values in. So 4 minus 2 is less than or equal to 2, because the 4 was the y and the 2 was the x. So 4 minus 2 is 2 is less than or equal to 2. So yes, it is a solution. So this one, alright, don't get thrown off by this. It says if 6y is a solution to this formula, what is the value of y? Well, we know 6. So we can put 6 in here. So we have 3 times 6 plus 2y equals 10. And we can solve this out by hand, which I'm going to do. But just want to remind you, you could also go and put one side in y1, and you could just type it in exactly the way it is. 3 times 6 plus 2. The reason I wanted to show you this was to remind you that the calculator doesn't understand y. You'd have to use x anyway. And then the 10, then y2, and then go into the table and find out where they were both 10. And it would be at x equals negative 4. Or we could do this by hand, and we'd have 18 plus 2y equals 10 minus 18. 2y equals minus 8. Divide both sides by 2, and y equals negative 4. Alright, so for graphing the inequality, so first of all we just graph the line. So y equals mx plus b, it starts at 1. This is not a fraction, so we make it a fraction by putting it over 1 for the slope, so it goes up 2 over 1. That's all we need. So y is less than, so there's not a line underneath. So we do the dotted line. And since y is smaller than this line, we're going to go below the line and shade below the line. Alright, so for this one, y is greater than or equal to x plus 3, so we start at plus 3. And since there's nothing in front of here, it's 1 over 1, so it goes up 1 over 1. And since there is a line under here, we have a solid line. And then y is bigger, so I put my pencil on the line, y is bigger than the line we shade up. All right, on systems of equations, if you'll remember, systems of inequalities, you'd actually have to graph both of these. The way to do that, let's start with this one here, just because it's easier. X is less than 2, so we'd have x is 2. So the line x is 2 would be there, and x is less than that, we shade on that side. I'm going to change colors for this one. Then for the other one, we would need to solve for y to graph it. So y minus x is greater than 2. Add x to both sides. Y is greater than x plus 2. So we'd start at plus 2, and it's 1 over 1, up 1 over 1. And y is greater than that. So it's this whole area here. So is 0, 4, 0, 1, 2, 3, 4 in the area that's shaded by both? And the answer is yes. So it would be a solution. The other way you could do it is just put these values into both of those and see if it's true for both of them. So y is 4, so 4 minus x is 0 is greater than or equal to 2. 4 is greater than or equal to 2, and that's true. But it has to be true in the other one, so x is 0 is less than true, and that's also true. So since both of those are true, it would be a solution to that system. All right, so that's the end of page 2.